Hi everyone, I'm Max. I'm a fourth-year stat student from University of Toronto. This is the presentation of a project I did with Professor Keith Knight. I will start with a portfolio management problem, then I will go through three typical reinforcement learning methods with a simple example, and lastly, I will recap the problem of interest and see how these methods perform on our problem. The story is, as a portfolio manager, how can we optimize our performance by manipulating the portfolio? We believe that we can train our computer agent via reinforcement learning. Reinforcement learning is an unsupervised learning method which trains the computer agent to try and learn. That is, by trying different policies, the agent learns from its mistakes and hopefully converges to the optimal policy. Our problem, as many other such problems, can be modeled by the Markov decision process. When we are at state Si-1, our current policy pi Si-1 suggests us to take the action Ai-1. And then we immediately get the reward Ri-1, and we wind up with the new state Si-1 with a transition probability P. An episode is a chain of Markov decision process from S0 up until the end. The portfolio management problem is very complicated to manipulate at the first glance, so we use a simpler example to demonstrate the reinforcement learning method. A car drives from S to G along the cliff, which are the gray boxes. We penalize the car with a very large negative reward for it falling off the cliff, and we compensate the car for it arrives at G. And we can also penalize the car for it wasting time hanging around the white boxes with a smaller negative reward, -1. The so-called tabular method restores every memory in a Q table, which is like this. And the Q table is updated following this algorithm. We call it Q learning. In each episode, the agent updates the value at each state given a particular action by adding the immediate reward after the action and the maximum value of the successive state among all actions, and then subtracting the value of the current state itself. Alpha here is the learning rate. The larger the alpha, the more aggressive it learns. And finally, the car will find the best path to G. Policy gradient is an approximation method, which is different from the tabular method. It learns by updating the weights of the action states. So the higher the weight of an action given a state, the higher the probability the agent will take this action when it is at this state again. The algorithm is like this. Alpha is again the learning rate, and VT is the direction of the update. It determines whether the action is granted to a larger weight or a smaller one. Lastly, we add a net to the algorithm. Deep Q network has similar idea as Q learning, especially in their updates, but it's way more powerful. The algorithm is very complicated to show, so we'd rather look at the diagram. A batch is a bunch of episodes which are sampled from all possible episodes. Essentially, we train our parameter with the evaluation net and update the new parameter to the target net. And the target net should give us what we want. All methods we have mentioned works for the simple cliff example. So this should be able to help us with portfolio management, because our problem of interest is designed to be very similar as the cliff problem. At each state, while the car in the cliff example is deciding which direction to go, we as portfolio managers decide how to reallocate the weight of our portfolio among three stocks, ABC, and cash. To make life easier, the three stocks are designed to be fairly different, where the price of A is always increasing, B is keep constant, C is always decreasing. The Q table is like this, and of course, we must all long stock A. And that is fortunately where our agent converges at the end of the day. In conclusion, all three methods can be applied here, though they take different time. Note that we oversimplify the portfolio management problem, and in reality, we may not have a convergence. Lastly, we found out that reinforcement learning is better to train an agent to understand stable environment rather than survive from a dynamic stock market. But understanding the historical market behavior is also very indicative for a portfolio manager. That's all for today, and thank you for listening.